Hello guys. First and foremost, I hope everybody is doing well. Sorry for the lack of uploads. I've been so busy for the past month. Um and also I've just been trying to expand my tutoring business. Um so in this video what I want to do is actually go over a calculus problem that I personally thought was very, very difficult. This is, of course, for Cal 2. So if you're in Cal 2, this is, for you. um, but Basically, we have this indefinite integral, and we want to go ahead and integrate it with respect to x. And so I'm going to go ahead and read it. So it says the integral of sine of the natural log of 2x dx. So we have to use a mixture of a few, actually maybe two integration techniques or three. And Basically what I'm going to do is I'm going to go ahead and show you guys how to do this one. Of course, we have to understand how to integrate, already by use substitution, etc. So let's just go ahead and get started. So the first thing I see here, and let me just kind of rewrite it. So we have the integral of sine of the natural log of 2x, and then all of this with respect to x, right? So basically, the idea here is we want to use, first we need to use substitution. So that's, step one. So steps, I'm going to write out the steps. So number one, use u substitution. And so what I'm going to do is I'm going to make u equal to 2x. So in this case, this is going to be u. So u will be 2x. So really, we're going to have the integral of sine of the natural log of, and it's going to be 2x dx, right? And it's this whole thing with respect to x. So basically, let's see, hold on one second. So we're going to make this equal to u. So we have the integral of sine of the natural log of u. And so we need to find du. So we know u is 2x, right? And now du is going to be, so du will be 2 dx. So then if we solve for dx, we say that dx equals du over 2. So again, if I have, if this is dx right here, I'm going to go ahead and put du over 2 for that, because that's what dx will be. Now we have the following, so we're going to go ahead and do the integral of sine of the natural log of u, and then it's going to be times, and we're going to do 1/2 du. So the 1/2 is a constant, right? So that's a constant, and we're gonna bring that outside. So we're gonna say 1/2 integral of sine of the natural log of u du. Right? So far that's what we have. We still cannot integrate it though, because it's actually going to be difficult to integrate that. Now, here is where here's where it gets very interesting, and basically, hold on, um, so let's see, hold on guys, 1 second. Okay, so here's where it starts getting very complicated. So, obviously we still cannot integrate this. It's impossible, right? So what we need to do is we need to use another variable, and of course, in this case, it's whatever's inside the sign part. So if I make this equal to v, so v is going to equal the natural log of u. So really, it's going to equal natural log of u. But the thing is, I'm not going to, at least I don't think I am, going to find, let's see, hold on 1 second, guys. du over e to the v. So this is du, right? So then dv, so basically what I'm going to do is I'm going to solve for u in this formula. So if I solve for u here, I basically basically raise both sides equal, like I basically use base of e to solve for u, because e to the ln of a is a, right? Because the e and ln cancel out, or natural log. So it's going to be e to the v equals e to the natural log of u. So what that'll give me is these two are going to cancel out, so then u will be e to the v. So so that'll be what u is going to be. So basically, u will be e to the v, and so we know that du itself is going to be e to the v dv, right? And I can't really explain why it's like that. It's just another way of doing it. It's you know, I guess it's another way of, you know, we'll basically see how this plays into the integral. Because if we do it the other way, and where we say v equals ln of u, so then you know, dv is 1 over u, etc., it's not going to work. So then basically what we're going to do here is we're going to do, so basically v is ln of u, so we know v equals, like I said, it's ln of u, so we're going to say 1/2 integral of, and it's going to be sine of, and it's going to be ln of u, or I'm sorry, sine of v, right? Sine of v, and like I said, v was ln of u. So, and then du itself right here, du is actually e to the v dv. So it's going to be times e to the v dv. So now we have an integral that we can actually integrate. And so basically what we're going to do here now is we're going to make sure to leave the 1/2 here, and we're just going to look at this as if we're integrating with respect to v. So we have sine of v e to the v dv. And so the way that this is going to work is, and so let me actually rewrite this as e to the v sine of v dv, right? So basically what I'm going to do is I'm going to use integration by parts. Now remember, integration by parts this is integration by parts right here. Integration by parts. So what we're gonna do here, and it's gonna go like this. The integral, and it goes u dv, and we're gonna say it's u v minus integral of v du. However, because we already used u and v, we're not going to use those variables. We're going to use another different variable, because the thing is, I don't want to confuse anybody and say that, you know, it's, I don't want to confuse anybody in this case. So I'm going to use, let me see, one second, guys. I will use HDW. So I'll use H, and then I'll do DW. So we'll just do H and then DW like this. It's still integration by parts, but we're using different variables. It goes HW, so HW minus the integral of W, and then DH. DH, I'll just do this color, DH. So really, we have 1/2 integral of, and it's going to be, it's going to go e to the v, so it's going to be e to the v, and then we have sine of v dv, so it's going to go like this. One second. E to the v, and then sine of v, and then dv, basically. So this is supposed to be a v, so sine of v dv. And we're going to do, this is going to be 1/2, and it's going to be, it's going to go 1/2, and we're going to multiply this whole thing by 1/2, right? So we're going to say it's u dv. So what I'm going to do is I'm going to define h and dw. So h is e to the v. So one second. So h is e to the v. So we know h is e to the v. Hold on one second. H is e to the v, and then h dw. So dw is going to be sine of v dv. So now we're going to do dh. So dh is still e to the v. So dh is still e to the v. Oh, and let me do it the color that I chose. So dh is still e to the v dv, and let's see, one second, and then w itself. So w itself is going to be another. It's going to be the integral of sine of v. So we know that the integral of sine of v is really going to be negative cosine of v. So w is going to be negative cosine of v. So we're going to plug this all these things in for the for integration by parts. So we have 1/2, and we're going to do times, and it's going to be hw. So it goes hw, basically h is e to the v, so we have e to the v, and then it's going to be times w, so w was negative cosine of v, so times negative cosine of v, so times negative cosine of v, and then minus, and it's going to be the integral of the negative cosine of v, and then dh, so dh was e to the v dv, so e to the v dv. So now we have something like this, and let me just kind of copy and paste this so that we can see it more clearly. So I can move it over here, and then we can see it more clearly. So this is what we have, and now what I'm going to do is I'm going to go ahead and put 1/2. I'm going to leave it on the outside, but I'm going to simplify this. So this simplifies to negative e to the v cosine of v, and then this is a double negative, so it's going to be plus the integral of e to the v cosine of v dv, right? And so that is what is equal to 1/2 times the integral of e to the v sine of v, right? So this is what 1/2 integral of e to the v sine of v dv is. And so from here, we're going to go ahead and do, so let's see. I think we need to do integration by parts again. But let's see here, 1 second. So let's see. We're gonna do integration by parts with 1 second, guys, hold on. Okay, so now what I'm gonna do is I'm gonna integrate this part, and this part we're gonna do again. So we're gonna do the integral of e to the v cosine of v now. So we're gonna say e to the v, so it's gonna go integral of, and it'll be let me do e to the v, and it's gonna be cosine of v dv. So it's gonna go e to the v, and then cosine of v dv, right? And basically what is going to happen is we're going to do and actually I was supposed to make I'm supposed to make e to the v dv, the other one, so it's going to be cosine of v and then e to the v. Let me use a different color. Hold on, guys. Cosine of v e to the v dv. And so this is going to be, again, like I said, integration by parts. So it's going to go, I'm going to do a dr. So it's going to be a integral of a dr. So we're going to do integral of a dr equals, and it's going to be a r. So a r minus the integral of r, and then dA. So dA is, what would dA be? It would be, just make it this one. So, what we're going to do is we're going to do integral of, and let me actually do it this way, integral of cosine of v e to the v dv is equal to, and it's going to be ADR, or I'm sorry, AR, so we know that A is cosine of v, and dr is e to the v dv. And we know that r itself, well, actually, it's going to be, we're going to do dA, so dA is negative sine of v dv, and then r itself is going to be e to the v, right? So now we're going to have the following, and let me move it down a little bit. So it goes, it goes AR, so cosine of v, and then times, and then it'll be e to the v, so e to the v, and then minus integral of e to the v, and then dA times negative sine of v dv. So it's going to be times, and it'll be negative sine of v dv, right? So, so now we have to simplify this. It's going to be e to the v cosine of v, and then it's going to be minus integral of negative e to the v sine of v dv, right? So then the negative cancels out again. We have e to the v cosine of v plus e to the v, or plus integral of e to the v, my bad, plus integral of e to the v sine of v dv. Okay, so that is what cosine of v e to the v dv is. Well, in this situation, it's what it is. So then what we're going to do is we're going to go ahead and grab all of this. I'm just going to go ahead and kind of copy paste here. This whole thing, we're just going to go ahead and copy paste. So, so what's going to happen is this whole part right here, we're going to replace with what we just did. So we're going to do e to the v cosine of v plus integral of e to the v sine of v dv. So it's going to be e to the v cosine of v plus e to the v sine of v dv. Plus integral, my bad, plus integral of e to the v sine of v. So it's this whole thing. And so, let's see, 1 second, guys. Actually, guys, I'm wrong. Oh my goodness. So we're not gonna, we're actually not going to, plug it in yet. Actually, I'm gonna keep integrating this until I find the actual integral. So this whole thing we know is equal to the integral of e to the v. So it's e to the v cosine of v dv. We know that that's the whole thing here. So this whole thing is equal to the integral of e to the v cosine of v dv. So we're gonna keep going until we actually integrate the whole thing. So now what we have to focus on is this, and so we need to find the integral of e to the v sine of v dv. So if I make, again, if I use I don't know, if I make, let's say, let's do u is equal to sine of v. So actually, let's do let's do, I don't know, I'm trying to think of another letter. L equals sine of V, and then let's do G, let's just do G. G equals e to the V. Or let's do dg, so u dv. So dg is e to the v dv. And so we know that dl itself, so let me just kind of do, I don't know, let me do a different color. Let me do this one. So dl is going to be cosine of v dv, and then the integral of dg, so g itself is just going to be, and let me get another color. I'm kind of running out of colors here, but I'll do red. I'll just do red. So G itself is going to be equal to e to the v. So the way this is going to go is the following, and we're going to do the integral of, and it's going to go, so we have sine of v, so sine of v, so it goes sine of v, so we're gonna have sine of v, and then e to the v dv, so e to the v dv, so let's do e to the v dv is equal to, and it's gonna be lg, so it's gonna be sine of v, and then times g, so times e to the v, so sine of v, e to the v, and then minus integral of, and then it's going to be g dl, so it's going to go e to the v cosine of v dv, so we're going to have e to the v cosine of v dv, right? Okay, and now this is what that integral is. So basically, now what we're going to do is we're going to go ahead and plug this whole thing in, plug this entire thing in for the pink part. So we're going to have the following, and it's going to be pretty long. So e to the v cosine of v dv equals, so the integral of this equals e to the v cosine of v plus, and it's going to go e to the v sine of v, so the quantity e to the v sine of v, and then minus integral of e to the v cosine of v, minus integral of e to the v cosine of v dv. So it's this entire thing, and notice that we now have these two things going on where it looks like this, right? So now we can use algebra to solve for the actual integral. So what I'm going to do is I'm going to add integral of e to the v cosine of v dv on both sides. So what this is going to do is the following. We're going to have 2 integral of e to the v cosine of v dv is equal to e to the v cosine of v plus e to the v sine of v. Now, these two are going to cancel out, obviously. And finally, what we're going to do is we're going to divide by 2, because we originally wanted the integral of e to the v cosine of v dv. So it's going to look like this. The integral of e to the v cosine of v dv is equal to, and it's going to be 1/2 times e to the v cosine of v plus e to the v sine of v. And this is what this entire thing is. Now, going back to the original problem, that is what this was here. So now what we're going to do is we're going to plug this whole thing, so this entire thing here, we're going to plug it in all the way over here. So let me just, again, let me kind of copy paste again to see what we had originally here. So this whole thing is what this is right here. So let me take off the circles. Hold on. So we're gonna go ahead and say that this is equal to 1/2 times negative e to the v cosine of v, and then plus, and it's gonna be the quantity 1/2 times e to the v cosine of v plus e to the v sine of v. Okay, and this is equal to 1/2 integral of e to the v sine of v dv. Let me write that a little better. It's equal to 1/2 integral of e to the v sine of v dv is equal to this whole thing. Okay. And now, so this is what this whole part is. And now what we're going to do is we're going to say this is equal to, and it's going to go 1/2, and we have times negative e to the v cosine of v, and it's going to go plus, and we're going to say e to the v cosine of v plus e to the v sine of v all over 2. So because basically when you distribute this, you're just going to put it all over 2, right? So then this whole thing, then when we distribute our 1/2 in here, we're going to end up getting negative e to the v cosine of v over 2, and then it's going to be plus, and it's going to go e to the v cosine of v, and notice that the 1/2 is being multiplied to this 1/2 here, so we're going to put it over 4, and then plus e to the v sine of v over 4. Okay, so now it's a matter of just cleaning this up. Notice that these two things I can actually distribute them. Let's see, hold on guys. So what I'm gonna do is I'm going to try and actually I'm gonna go ahead and actually what I'm gonna do is I'm gonna take out the 1/2 or the common denominator if I can. So let's kind of see how this goes. So if I try and plug in. I don't think I can plug in u and v yet. Because u was e to the v, and let's see, 1 second, guys, 1 second. Okay, so what I'm going to do is the following. I am going to try and add all of these, and then we're going to factor out the fraction. So negative e to the v cosine of v plus e to the v cosine of v over 4. So these two basically here. If you just look at this on its own, what I can do is I can take out a 1/2. So if I do that, I get 1/2 times negative e to the v cosine of v. And then it's going to be plus 1/2 e to the v cosine of v. And then, of course, we have the plus e to the v cosine of v over 4. So then this entire thing basically becomes the following. Or, I'm sorry, plus e to the v sine of v over 4. So then what I'm going to do here now is I'm going to try and so I'm going to factor out this negative e to the v. So, or rather e to the v cosine of v in this case. I'm going to factor it out. So what I'm going to do is this. So 1/2 times, and it's going to go negative e to the v cosine of v times 1 minus 1/2. And then what I'm going to do is I'm going to say we have negative 1/2 times negative e to the v cosine of v times 1/2. So then this becomes 1/2 times negative e to the v cosine of v over 2. And basically we still have that plus e to the v sine of v over 4. So then what this becomes is negative e to the v cosine of v over 4, and then plus e to the v sine of v over 4. Okay, so what I'm going to do now is I'm going to go ahead and plug everything back in that we had talked about at the beginning of this problem. So like u and v. So basically what I'm going to do is I'm going to so we had u equals e to the v. So let's see, hold on 1 second. It was u was e to the v, and we know that, so v was natural log of u. So if I plug in v actually, so I'm going to say v, we know v was natural log of u, right? We know this was v right here. So we're going to say negative e to the natural log of u cosine of natural log of u, and then all over 4 plus e to the natural log of u, and then sine of natural log of u all over 4. So then the u kind of cancels out. This becomes negative 1 times cosine of natural log of u all over 4. And then this also cancels out. So it's going to be plus sine, or plus, I'm sorry, plus And actually, it shouldn't be, it's going to be u, it's going to be negative u here, because this part comes down here. It's going to be negative u and negative u, cosine of ln of u over 4, and then this is going to be plus u sine of ln of u all over 4. Okay. And we know that u was actually going to be, let's see, u was originally 2x, if I remember. Yes, u was 2x. So if I put that in, I'm going to say this is negative the quantity 2x, so because u was 2x. And like I said, u is basically this here. So it's going to be negative 2x, so 2x cosine of ln of 2x, and then all over 4, and then plus, and it goes 2x, so 2x sine of ln of 2x, and then all over 4, right? Okay, so this is going to be negative 2x cosine of natural log of 2x over 4, and then plus 2x sine of ln of 2x over 4. And now what we have to do is we have to simplify the what is it? The like the fraction, right? So we have negative x over 2, so negative x cosine of ln of 2x all over 2, and then plus, so it's supposed to be 2x here, and then plus, and then it's going to be x over 2 sine of ln of 2x. So then if I go ahead and just grab the x over 2 out, I'm going to say this is x over 2 times negative cosine of ln of 2x, and then plus sine of ln of 2x. And I believe this is the final answer. Oh, and also, hold on, I forgot to do one thing. I forgot to do one thing at the very end here. So what I was gonna do is literally multiply this entire thing by 1/2. At least I think that's what, you know, or at least I think, because basically we had, hold on one second, guys. This problem is really difficult. Or actually, no, I'm wrong. This is the final answer. Sorry, guys. It's gonna go like this, actually. So we're gonna do, I'm gonna just write it the following way. 1/2 x, and I would write it as sine of natural log of 2x minus cosine of natural log of 2x, and then plus c. So this, guys, is the final answer to this problem. I do apologize if I was pausing a lot in this video. Like I said, this was really hard. I had to look back at my notes because it's a very lengthy problem, and it's hard for me to remember all the steps. Yeah, so hopefully this made sense, guys. Like I said, this problem was super hard, but this is how it's done, and this is how, this is how we this is how this problem is done. So this is actually one of the hardest problems I've ever done. Well, it's not the hardest one, but it was definitely a challenge because it was just, there was just a lot going on with, with integration by parts um, as well um, as U substitution or UDV and all that stuff. So, with that being said, guys, I really hope this helps. If anybody does have any questions over this, please let me know. And also, please like, comment, and or subscribe. And I will see you guys in the next video. Bye, guys.